Nuclear fusion. In this video, we'll define fusion and talk about how the sun and us uses it and how we aren't able to use it for power. In all nuclear fusion, we are combining small nuclei into more stable, large ones. This is the opposite of fission, in which the nuclei were dividing. This occurs constantly in the sun. I have the reactions here for you. Although this wouldn't be something that you'd have to memorize, it does let you see how the smaller nuclei here and here are combined into larger ones here. And you can see them combining again here and here, into here and here, and so it continues. We are not, at this point in time, really able to use nuclear fusion as power. Now, with that being said, it would be awesome if we could, because we wouldn't have any radioactive waste. We would actually get more energy from fusion than what we do from fission. Fission is how we currently get nuclear power. Also, the fuel is very cheap, and so this would actually be an amazing source of power for us. So why can't we use it? The main problem with this is that in order to get this to happen, you first require millions of degrees Celsius. So yes, we can get so much power out of it, but we have to put a lot of power into it. We have to be able to keep it at that power. And even bigger of an issue, we have to be able to contain that material at those high temperatures. So they are working on doing things like this. This is one example of a Lockheed Martin design for a nuclear fusion reactor. But one of the ways that they've talked about doing this is you have a series of magnets. The blue netting that you see around here, here, and here would be magnets. And then this big circle here would be the material in the plasma state. And it would be actually held, rather than by a container, it would be held by the magnetic field. With all this being said, right now it ends up costing more money than we get in money back from creating the power, and so we are stuck with fission, with all the problems that we talked about in that video. Now, even though we can't do anything particularly productive with this, we as human beings are very, very good at destroying things. And we are able to use this idea to destroy things very, very well if we'd like to. So we talked about the atomic bomb, which uses fission, but we also have something called the hydrogen bomb. And you may have heard of this in your history classes. This is a bigger, badder bomb in some ways, the idea being that it's more destructive. Luckily, we've never actually used this in warfare, but it's an interesting thing to talk about regardless. So we talked about the fission bomb in the last video. If you haven't seen that, go watch it first and then come back. This actually is a little bit more complicated than that because, like we talked about in the last slide, we require huge amounts of temperatures in order to get a fusion reaction to happen. So how do you get these high temperatures required for fusion to happen? Well, that's simple. Set off an atomic bomb. So a hydrogen bomb actually has an atomic bomb inside of it. Now, that being said, you also have to set off the atomic bomb, and so you end up with a typical conventional gunpowder of some sort in there as well. The gunpowder sets off the atom bomb sets off the hydrogen bomb, and then that is your hydrogen bomb. There's actually no critical mass for the fusion bomb, except for, of course, within the atomic bomb itself. The interesting thing about hydrogen bombs is they actually have less radioactive exposure to the environment. So even though they create more destruction because they have more energy, the nuclear fallout isn't as bad. And that's because the atom bomb that's inside it is the only thing creating radioactive waste. The fusion part of the bomb is not creating waste. And so we can keep the atom part of it, the fission part of it, very, very small, just big enough to set off the hydrogen bomb, and keep the radioactive levels pretty low. Which isn't exactly to say that the hydrogen bomb is a good thing, but this is one slightly better aspect to it. So this also makes it powerful in a smaller package, which is convenient if you're storing huge numbers of them in missile silos around the world. And again, we luckily have never actually used this. The other two bombs that we already talked about in the other videos that have been used in warfare were atom bombs. So in review, fusion is when nuclei come together. If you are having a hard time remembering the difference between fusion and fission, think about what fuse means. If you fuse two items together, you're merging them together. That should help you remember. So fusion is in contrast to fission, which is when nuclei are split. Fusion creates more energy than fission, but harnessing it is very, very difficult, and so we aren't quite able to do it to create a power supply like a nuclear power plant. We are, however, able to do it in an uncontrolled setting because that doesn't take nearly as much technology, and we can use it in bombs because of that.